In this presentation, we are going to look at differential equations. So what we're doing is we're looking at a bank balance, and the bank balance is denoted BT of an account. The bank balance of an account is subject to continuous compounding and a net outflow. The bank balance varies with time according to this equation here. So this is the equation we're going to use. dB dt equals R times B of t minus 1. Okay. And that essentially what we're going to do is rearrange that. And what we're told also is, where is it gone? Let's go back up here a second. There, what we're told also is, I went down too fast there. The balance at time zero is P. Okay, P. And by solving the differential equation, find B of t. Okay. So that's what we have to do. So essentially what we're going to do is set this up as a differential equation. And I've gone off another blank page here again. There we go. So that's where we are now. So dB of dt equals, this is what the equation we've got. Okay. This is what we're told in the question. Okay. Just as b is a function of t, but just for the sake of making the notation easier to read, what I'm going to do is just b of t, just call b of t, just call it b from now on. Okay, so r is a constant times b, rb minus t minus 1. Okay, so what I'm going to do is rearrange this equation here as follows. Okay, so we actually have it as sort of structured as a linear differential equation. Okay, first order linear differential equation. In this presentation, by the way, I'm not really going to get into too much about how to do these. This is more sort of a worked example rather than an introduction to how to do these problems. So if you're unfamiliar with what I'm doing here, or in terms like integrating factor, I suggest you look at some of the other videos I have made about this subject area. So I'm not introducing as much in terms of new material in this one. But essentially what we have to do is construct an integrating factor here. So the component I'm going to pick out here is this minus r. Okay, don't forget the minus sign. Okay, so it's whatever constant there in terms, or whatever function is there before the b. So what we're going to do is use this down here, and this is put it into this formula for constructing the. So I'll just to be clear about this, whatever is in here goes in here. Okay, so the integral of minus r dt. Now r is a constant, so essentially what we have here is just when we integrate that, it's minus rt. So the exponential of minus rt, or otherwise we'd write it as follows: e to the minus rt. Okay, so that one was rather straightforward actually, to how to compute that integrating factor. Okay, so I'm going to go down now. By the way, if you're essentially, this is a big part of this. If you're unfamiliar with this term here, integrating factor, you've gone way too far in advance. So I suggest you sort of backtrack a bit and learn about differential equations and come back to this. So what I'm going to do now is actually we're going to set up our equation here. We have b here. So essentially, first off, I'll just remark that we have our integrating factor here times b, and we have our integrating factor here. E to the minus rt. Okay. Now the t plus 1. Essentially, what I'm going to do here is just for the sake. I'm just going to go back up to the equation I wrote up earlier. This part here, t minus 1. I'm just going to temporarily call that minus t plus 1, just because minus signs can be very troublesome. Okay. Now, so that is where this minus t plus 1 comes from, and I'm taking that minus sign outside of the integral. Now, just be careful if you do stuff like that. If you can get any sort of constant out, a minus, or just do so, just it makes your integration much easier to work with. Okay, but and I'm actually dreading the fact that I might actually forget about that minus sign later on in this presentation. But just don't forget that it's there. So what we have to do here is integrate this part here. Okay. And what I'm going to do here is use integration by parts. Okay, so I'm going to let you, and if you're unfamiliar with integration by parts, I suggest you sort of have a good look at that. What I'm going to do is let u equals t plus 1 and get the derivative of that. So du dt is equal to 1. So du is equal to dt. Okay, so that's this part done here. Okay, Now the rest of it is I have to find v, so I'm starting off with dv Okay, and that's e to the minus rt dt. To find v, I integrate it. So v is the integral of dv, is the integral of e to the minus rt dt. Okay, now that one's straightforward enough, but just remember when you integrate an exponential that has a constant term in the power, you have a minus r there. It goes down below. Okay, so just remember when you're integrating functions like that, that you would put the minus r or whatever it is in the right place. Very often, I'll just scrub it out and show you where people get this wrong because they're thinking about integration or differentiation. They might put in something like this. I'll be honest with you, I've done it myself a few times. So this is where you just be very careful about that sort of stuff. That's wrong, what I have there. The correct answer is minus RT over minus R. Okay? So we have U, we have V, we have dV, we have du and all that. So now what we're going to do is, this is our general formula here for integration by parts. That one there. I, the integral, equals U of V minus V du. Okay. Now, just remember the minus sign has to go in later, okay? Because I've sort of done whatever in the integral. I did not look at the minus sign yet, okay? You could actually rearrange that formula and put in the minus sign, but essentially after I get to the end of this, I have to put in the minus sign or and multiply everything by minus. So u is straightforward enough. It's t plus 1. Okay, that's u there. V is the e to the minus rt over minus r. Okay, and that's in brackets there. And that's in brackets. Okay. The minus the integral. So du is equal to dt. Okay, that was straightforward enough. Okay, and v is just as I have it up there, e to the minus rt over minus r. What I'm going to do is actually take out that minus r there, and I'm going to bring it outside to the integral, and I'm going to change the sign there. Just make it a little bit easier to follow. Okay, and that's a very straightforward integration. So I have e to the minus rt over t plus 1 over minus r plus 1 over r, and then we do the integral of that, and it's the same one as we've done before. It's the same one again. Also, we don't have to worry about coefficients of undetermined coefficients, not for a while anyway. So at the end, you sort out the coefficients. Okay. Do you know what? Actually, it might be a good idea to put them in. Actually, so I'm sort of jumping ahead of myself. I think actually it now is a good time to put it in, just to make sure that it's sort of not forgotten about. Okay. Or actually, no. I have to do my minus sign thing yet. Sorry, very close to doing it. So I'm not fully finished it yet. So e to the minus rt over t plus 1 over minus r minus 1 over r squared e to the minus rt. Okay. Now, what I've done earlier is I have a minus sign that I have to sort of incorporate now. So I have to bring in that minus sign. Okay, so essentially what I'm going to do is I'm going to multiply by minus is to negate this answer. Okay, and the reason is because I've not factored in that minus sign yet. Okay, so I'm just going to multiply that by minus 1 essentially. So it's e to the minus rt over t plus 1, and we can put the first term just over r, and the second term over r, just get rid of that minus sign, plus turn this minus sign in, just change those two signs basically, that's all we have to do, times e to the minus rt. Now we put in our coefficient of undetermined coefficient there, because we're pretty much finished now. So now we can put it in. Okay, so I can tidy this up a little bit. What I could write here is e to the minus rt times t plus 1 over r plus 1 over r squared plus c. Okay. So far, so good. You can even tidy that up a little bit further, but we don't really need to. Okay. Now, so that is our integral taken care of. That's the answer we have. So I'm just going to go back up here, and essentially what we have done is we've got all this integral sorted out. I've just accidentally taken out the integral sign, but we got that entire integral sorted out, and that entire calculation sorted out. So there we go. What we could do now is just actually sort of go back to working with this, and just so we'll essentially what the answer we have there below is b is equal to minus that. So let's start this again. B e to the minus rt is equal to e to the minus rt over t plus 1 over r plus 1 over r squared plus c. Okay, now let's be careful with that c from now on. Okay, you notice that we have e to the minus rt, that we can sort of try cancel it out. We can cancel it out there, cancel it out there, but we have to divide it there. Be very careful about that. So b is equal to t plus 1 over r plus 1 over r squared plus c over e to the minus rt. Now you can simplify that last term there, c to the minus rt, if you just change the sign, or essentially just rewrite it as follows: c to the e plus rt. Okay? So pretty much this is a pretty good place to be right now. Okay? Now, earlier on we were told that at time t equals 0, the balance was p. Okay? So, c is an undetermined coefficient, okay? But p is like some specific value, okay? So, for r and p are like specific values, they're not undetermined coefficients. So let's use that. P at time equals 0, so we have 1 over r plus 1 over r squared plus c to the er0. Okay, anything to the power of 0 is 1. Okay, so we have c to the power of 1, which is just c. Okay, so there we go. That's where we are. I'm just going to pause it for a second, catch my breath. So let's write in c here. C is equal to p minus 1 over r plus 1 over, or minus 1 over r squared. Okay, so that is our value for c, and it's all it's given in terms of all the notation we would expect for our formula. Okay, so putting c back in to our formula, we would have b equals, let's just go back up here, what is it, t plus 1 over r plus 1 over r squared plus c, so c is this part here, p minus 1 over r minus 1 over r squared times e to the plus rt. Now I think I'm a little bit out of shot there. Okay. Ultimately, I think what you could do there is you could rearrange that if you wanted to, in some general way, shape, or form. You can actually just expand it out a little bit further, but essentially we're finished now because we have all of the terms there that we need. That you could sort of just like let this last term multiply it out properly, okay, which is what I'm doing here. But ultimately we're sort of finished now, so it's essentially, you could try and tidy it up, but I actually would sort of personally prefer it in that sort of form myself, that you could sort of see all the individual terms. You might find some calculations, but essentially we're done. So I'll leave it there. That's the end of this video. Differential equations.